Ionic equilibrium questions we are discussing. Which of the following is only Bronsted-Lowry acid but not Arrhenius acid? Bronsted-Lowry acid means it should be able to release protons. Arrhenius acid means it must contain protons. So here you see NH4 plus is the best example. NH4 plus can release protons. Which of the following species acts as Bronsted base but not acid? Bronsted base means it should accept proton, but not acid means it should not release proton. So you can see H2PO2 minus, because H2PO2 minus is coming from H3PO2. H3PO2 is hypophosphorus acid, which is monobasic acid. H2PO2 minus is formed. It can accept a proton, but it cannot release any more protons because these hydrogens are directly attached to phosphorus. Important point. Which of the following can act as Lowry-Bronsted acid as well as base? Means it should release proton, it should accept proton. So that happens in this case because PO4 minus 3 is formed when HPO4 minus 2 loses proton. So it is losing proton, so acid, it can gain a proton and it can become like H2PO4 minus. So both possibilities are there. It can accept, it can release. So option 3. Which of the following is neither Bronsted acid nor Bronsted base? Means it should not release acid and it should not accept acid. So you can see here BF3 because it can accept proton, HCl is formed. It can accept proton, it can form H2SO4. Of course, it can release also SO4 minus 2. This can release proton, Hi gives us I minus. This is nowhere. So this is your answer, BF3. Which of the following is a Bronsted acid but not Bronsted base? Bronsted acid means should release, base means should accept. H2S is not able to accept. It is releasing, but it won't accept. Okay, you didn't say any time H3S plus. It is not there now, so it won't accept. It can release SH minus, you have seen. The conjugate base of hydrozoic acid is N3H. Its conjugate base means N3 minus. One proton is to be removed, N3 minus. Identify Bronsted-Lowry acids in the reaction given below. Bronsted-Lowry acids means they should release proton. Here you see AlH2O taken 6, here AlH2O taken 5, OH, that means one water molecule has lost its proton. So this is definitely your component. This is given as A. So A is here and A is here. And here HCO3 minus is coming from actually H2CO3. This arrow is both sides. H2CO3 can release proton, so it is D. H2CO3 can release and aluminum with 6 water molecules can release. Conjugate acid of HPO4 minus 2. Very, very simple line. Whenever such kind of questions are there, conjugate acid of HPO4 minus 2. Just add one H plus. H2PO4 minus. Conjugate base of HSO4 minus. Remove this proton. So when proton is lost, SO4 minus 2. Of the given anions, the strongest Bronsted base is, here you see ClO minus, ClO3 minus, ClO2 minus, ClO4 minus. As we know, HClO4 is the strongest acid. So ClO4 minus is weak base. In this row, HClO4 is the weak acid. So ClO minus is the strong base. So you're asking strongest Bronsted base, that is ClO minus. Among the following relatively weak base is, actually when these are given HF, HCl, HBr, HI, if you see, HI is the strong acid. So I minus is weak base. I minus is the weak base because HI is the strong acid. If acid is strong, its conjugate base is weak. right? Done. Among the following, relatively strong base is relatively strong base means it should come from a weak acid. It is coming from H2SO4, strong acid. It is coming from HNO3, strong acid. It is coming from HCl, strong acid. This is coming from acetic acid, weak acid. When acid is weak, its conjugate base is strong. So answer is CH3COO minus.